So, as Sarah said, I'm going to talk about S is for system, a post-it presentation. So I chose not to use PowerPoint, so I'm using post-its. Of course, requirements engineers, many of them love post-its, me included. So that's what I'm going to talk about. Slight rustling, apologies. So this is a recording. This is not a recording. So interesting that Sarah said she didn't prepare for very long for this. Over my time at the requirements conference, I found that the less I prepare, the more I enjoy my presentations, and in general, I get better feedback the less I prepare, which is lovely because it's an excuse not to prepare. Anyway, unusually, I did the whole run through of this last week because we needed a backup in case the internet went down. So this is the recording, so that if we had to go back to that, it was clear that it was a recording. So this is not a recording, this is live. Unless you're watching it back over the internet, in which case maybe it is. Anyway, so I'm going to talk about why S is for system. Implicit in that is that it is not just for software. So why did I need to do a backup? Why did I need to do a recording last week? Well, in case, quote, the internet goes down or we lose connection. I thought that was interesting, and maybe that has some implications or could be used as an example for why S is for system. So rather than looking at what could go wrong and why we might lose a connection, I thought, what do we need to have a successful connection? Or what you might say is, if we wanted a video conferencing system, what would we require? Okay, so from my end, I'm sort of going to trace it from me to the internet and then to each of you, if you like. What do we need? So I need a computer of some sort. That's supposed to look like a hard drive. I need some sort of webcam. I need some sort of microphone. Speakers. Some kind of monitor. Some sort of keyboard. And some sort of mouse or pointer. But of course, that all looks very old-fashioned, like some sort of desktop. So maybe I have a laptop. Or maybe a phone. But of course, a laptop and a phone provide all these things. It's just a different package that has all the same bits of hardware on it, if you like, and some software. I'll probably need a modem. Maybe all those things need power. Some of them may be battery operated, but of course they'll have to have been charged. And then I'll need Wi-Fi. All of which will be useless unless I connect to the internet. I realize there's a lot of detail in there. Calling the internet one thing or the web is kind of stupid, but all those things must be in place for me to, when I speak, for it to get to the internet. And then of course, you need all those things at your end for you to be able to see it. There's a little bit more than just, they're principally hardware items, of course, but of course, many of those things include some software. What else do we need? Well, we'll need some money. Why do we need money? Well, some of these things require subscription. You need to pay for your internet service provider, your broadband supplier, and so on. You may need software. I presume that's supposed to look like a CD-ROM. Interestingly, or a CD, interestingly, you can't really have a picture of software on Google Images. If you put software icon, almost all you get is a CD, which of course is a bit old-fashioned, and most software you download anyway. It's either a CD or it's a CD going into a drive. That's what represents software. Software is rather abstract. Maybe I'll talk about that again. And of course, some of those things may be on the cloud. Partly just showing off the fact that I've got a cloud post-it. So And of course, if the software is coming off the cloud or some of these services are running on the cloud, then of course, in turn, that means you must have the internet working. So what else? Well, a user. So me at this end of the whole chain. Now, where there are users, I find generally there are feet. Users, there are feet. Is this going to make any sense? Where are the users? There are also hands. What I mean by that is where there are users, there are feet, means feet can accidentally disconnect things. So the power, the cable might get knocked. Fingers, elbows might accidentally press keys and therefore you lose your connection. For all this to work, as well as me being here and all these bits of hardware and associated software working and the whole chain to work, because of course any break in the chain could potentially either slow it down or make it glitchy or lose the whole connection. We also need some people in Pisa, because of course all the, Alessio and all the people in Pisa need to be there to set it all up. Well, I touched on cables. All these things have cables. Or perhaps more realistically, the cables might look a bit more like that. So this relates to the feet that could knock the cables out. More generally, there's other user types, other physical stakeholders, other people involved. And where there are people, some of those people may have things like shovels. What do I mean by people with shovels? I mean people digging up the road. They may have big diggers. They may accidentally cut through the link that gets you to the internet, all of which could break this chain. What else could threaten this whole chain of connections? Well, people using Xboxes that might be using up some of your Wi-Fi. So luckily, it's only lunchtime here, so my 18-year-old is still asleep. So I know for sure he won't be using his Xbox. For the Wi-Fi, I'm the only one using Wi-Fi. When I did the recording of this on Friday, luckily that was at 3 in the afternoon, so I knew he wasn't going to be able to use the Wi-Fi. That's a lot of stuff that could all go wrong in some ways. I'm not going to do much rustling. That should be the end of the rustling. So I could summarize all that because that was a lot of specific things related to a video conferencing system. But more generally, any system would consist generally of the following elements. Software, which I know is close to some people's hearts. Hardware. Users, stakeholders, and so on, people. And context. So very generally, any system will can include all of those things. Sorry, I've just got an annoying dialog box. So when we come up with a solution, when we are given a problem to solve, the problem can be solved by some combination of software, hardware, users, and things in the environment. So when we decide on our initial design, our architecture of our solution, we decide what we're going to do in software, what we're going to do in hardware, what the user is going to do, and what the environment will do. Some systems rely very heavily on the user doing things. So the system as a whole will achieve some behavior that we require, that is part of our requirements or needs of what the whole system must achieve. But some of those things will be achieved by the user, not by the system itself, or so the wider socio-technical system, including the users, but not the actual hardware or software, certainly not the software. We may choose to do some functions in software or in hardware or in a combination. That's a choice. Some things may be done in the environment. In many domains, you rely on things like gravity. Gravity. You're using gravity. So that's not something that you build in any sense. It's not something that you're expecting the user to provide. It's just there. So a problem is solved by some combination of these things. I would argue never just software. So this is just a few points about why I think hardware, so I'm talking largely about software and other things in a system and why systems are more than just software. So of course, most people involved in requirements engineering are familiar with software and the failures that can go with it. And most people are familiar with and naturally consider user behavior, slips, mental blocks, cognitive overload, all the things that users can do wrong or that can cause problems. But people perhaps don't think so much about hardware issues. Very simple summary, not complete, of some of the things that you might consider to do with hardware. So these are things that are definitely more complex, another level of difficulty than the sort of errors and problems you have to consider in a software environment. So hardware, things are manufactured, and there could be, things could be manufactured in different factories, and there will be variability. Variability in the tolerances and sizes and performance of your pieces of hardware. Hardware artifacts are assembled into components and into bigger subsystems and systems, and assembly can lead to issues. Use, people will use them in different ways to what you might have envisaged, including in different contexts, in different environments. Wear, things wear differently, and when they wear, they perform differently. And if you have a system that has some new and some old pieces of equipment on it, then some of them are performing better than others. How things are maintained is important. And of course, you can write requirements for maintenance and many of these other things, but how they're maintained has a huge impact on how they perform. And then, of course, faults and failures of the hardware. So, interesting that I've kind of got quite a lot out of needing to do a backup presentation, but it was because it illustrated exactly the sort of things I wanted to talk about. So what prompted me initially to think of this as a subject for this keynote? Well, many times at the RE conference and at REFSQ, I hear presenters saying things like, they talk about software requirements or software intensive system requirements, or software systems requirements. Many people talk about software about requirements as if they are for software, as if they are just for software. Close to half the presentations, I would say, seem to assume that requirements are for software. And there's a specific quote, it's by a well-known member of the requirements community, but they shall remain anonymous to protect them. So requirements are for software because software is more complex than systems. This is what a prominent member of the requirements community once said, and I may come back to that. So there's those jokes about there are two types of people. One of the ones I've seen recently that I liked was there's two types of people. One, those who can extrapolate from incomplete information. I quite like that one. But the other one, this one, I like. Unfortunately, you have to read it rather than saying it. It only really works if you read it. And I'm sure you're probably all quite familiar with it. There are only 1-0 types of people. Those who understand binary and those who don't. So you'd have to be thinking in binary terms to understand that that means 2 and not 10. So there are 1-0 types of people. Another way of looking at this, and in a way, perhaps this is part of what I'm getting at, is there are two types of people I see in the requirements community. There are those who think that requirements are for software, and there are those who think requirements are for systems. And I'm going to discuss the main body of this presentation is software and systems and similarities and differences. Don't need that. Excuse me. So, software and systems. So I'm going to discuss some of the characteristics of software and of systems, but first I'm going to illustrate it with a simple example from a domain I'm well known for, which is aerospace. I worked for Rolls-Royce for 14 years. So, as you can imagine, a control system for a jet engine is a very complex thing. And there are various different terms used for a control system, engine control system, just control system, EEC, engine electronic controller, FADEC, full authority digital engine controller, etc. So I'll try and clear a little bit of that up. So a FADEC, which is just software, full authority digital engine controller, So a FADEC is a very complex piece of software, of course. Many hundreds of thousands of lines of code, realistically of the order of 1 million. Lots of control loops. For example, in a Rolls-Royce engine, there are of the order of between 10 and 20 control loops that set thrust. So at any time, it's about 15 loops are all pieces of logic, are all simultaneously working, as it were. At any point, one of them sets the thrust. So clearly an extremely complex piece of software. There are numerous measured and calculated values. So you get values from the engine measures things and the aircraft measures things. And some of those are just measured. Some of them are calculated from other of our values and so on. And all these things have to be range checked and cross checked and so on. And of course, to allow for various failures and so on, there's an awful lot of code for unexpected and undesired behaviors. So FADEC, the software for a jet engine, is indeed extremely complex. Meanwhile, the control system, the wider control system, has thousands of components and hundreds of LRUs, line replaceable units. Now, line replaceable units vary in size from a FADEC is a line replaceable unit, the whole thing. But then it can also be things like cables and pipes and brackets, so it can be quite small things. And some of those LRUs, there may be multiple instances on an engine. So a speed probe is an LRU, but there are many speed probes that measure the speed of the engine. A control system is developed with many tens of suppliers, a very rich global supply chain. And of course, the control system includes the FADEC. The FADEC is part of the control system. So by definition, the control system is more complex than the FADEC. So one specific bit of software that's very complex on an engine control system is scheduling, or an aspect of the software is how you schedule the software. So there are numerous calculations that go on, that are scheduled and continually operate, some of which operate every 5 milliseconds, some of which are 10, 20, 50 milliseconds, 500 milliseconds. But for some functions, you need to be able to show an end-to-end response time from when an event occurs until the engine responds. The control system responds and therefore does something to the engine as a result of the event. And of course, that end-to-end scheduling means that or that end-to-end timing constraint means that the scheduling is very complex, because if you're measuring a value and using that value to calculate another value, then the order and timing of all those calculations is extremely complex. And much of that is constrained by hardware. So how quickly is it possible to measure things? How accurate and how quick? To what level of resolution and so on are the hardware devices? How quickly can they measure? But also, of course, some of the things they're measuring only make sense over time. A rate of change of speed, if you're looking for a change of speed, a sudden change of speed or a proportional change of speed over a time, then it has to take sense. So a lot of this is constrained by hardware. A lot of the complexity, even of a primarily software thing, the scheduling of the software, much of the complexity comes from limitations and behaviors of the hardware and the environment. So, software and systems, some mainly differences, some characteristics of them. So, software is primarily deterministic. So, you put in a particular input and you will get the same output because it's the same thing every time, if you like. Systems are principally probabilistic. You have a level of confidence that certain things happen. You can't be certain. So systems are kind of logical. They're about zeros and ones. Systems are more about percentages. How likely is it that certain things happen? With what level of confidence? Because of that, software is inherently predictable. Guess what? Systems are less predictable, unpredictable. An interesting one, Software, if you duplicate it, if you copy it, the copies are identical. Whereas hardware, and indeed users, non-system things, so things in the more systemy domain, no two are identical. No two humans are identical, however much we may think of user types. No two physical components are identical. Because some of these build on each other, of course. So to some extent, you could say that software is fairly certain. And systems are less certain or uncertain. Software is generally well-bounded. We know what we're doing in software. The edge of software is clear. And guess what? Systems are less well-bounded, or even go as far as saying unbounded. I would argue that in general, software, the scope is set. We decide what we're doing in software, and having decided that, we take inputs, we do stuff in software, and we produce outputs. The boundary is clear, the scope is set. In hardware and in systems in general, scope is often negotiated. You might start with an idea of what the scope is likely to be, but during the course of a system development, it tends to be negotiated. It's much less clear. Software is inherently abstract. It's intangible. Whereas systems are concrete and tangible. The whole software domain, the software that you make, is in effect invented. It's something that you make. It's all in scope. What you decide is going to be your system of interest. You can do what you want with. You invent it. Much of system is real. It's physical things. It's real. Because of some of these things I've said about the scope being set, and you're inventing the software, pretty much everything in the software world is in your control. And guess what? In systems, there are things that are outside of your control, how users behave, tolerances on manufactured, engineered items, hardware, and so on. Some of these may be contentious, but they're my view. It's a keynote, I can say what I like. I would say that the software view of a system is inherently inward-looking. It is looking inside the box at the software. It is inherently an inward-looking discipline. Whereas systems is inherently an outward-looking view. I would argue that software is relatively easy to test. You can run multiple tests that takes up software time, and of course, as memory and processing power has increased at a crazy rate, it's relatively easy to test software to death, so you know what it's going to do. It's relatively easy to test. It's not trivial, but it's relatively easy. Systems, harder to test. What do I mean by that? Well, in simple terms, in software, if you do X, you get Y. If you get an input of X, you do Y. And to test things, you input X and see if the system does Y. But the requirement says you do that you write a test script to address that, to show satisfaction of that requirement, and you run a test and you see whether it works. For a system, it's a bit more difficult than that because it's probabilistic rather than deterministic. So you could probably say something more like, in situation A, with a system configuration of P, a user type C will be D% likely to do E. You often can't say much more than that. So it is much more complex, much less predictable. And then one I've only got to put on, I've been pairing, one I'm only going to put on system is that in systems, there is much more emergent behavior because you've got the interactions of all the hardware, the users and the environment, much more interaction than you get in systems, much more unexpected emergent behavior. when you get in software. So that's maybe all my opinion. Some of you might be thinking that's just my opinion. Can I really back that up? Well, I'm going to try and back some of that up by looking at some of the theories, if you like, some of the theoretical basis on which software and systems engineering is based. So one thing will be Michael Jackson's The World and the Machine. So for those not too familiar with Michael Jackson's World and the Machine, you have the world and you have the machine. And the intersection between the world and the machine is what Jackson calls the shared phenomena, which is the interface. It is that part of the machine that is visible to the world, so it's the interface. And requirements are written is to define the shared phenomena in the interface. Interesting. So at this point, I would say users use systems. Why do I say that? So Michael Jackson largely talking about software systems, but even his overall model for software systems talks about the world and the machine and the shared phenomena between the world and the machine. The shared phenomena in the interface is the system boundary. So people don't care about what software does, they care what systems do. So one thing I think that comes out with some people in the requirements community is that whatever the problem, the solution is always software. People think they've got a problem and they think, how are we going to solve that? Implicit in their thinking is with software. What software are we going to use to solve that? So I've got a little story related to that. Canadian flag. Excuse me. So a couple of years ago, I was going to do some work in Canada, and when I landed at the airport, I got to immigration and showed my passport, and the immigration person looked at my passport and said, "Oh, what's your reason for coming to Canada?" And I felt the blood drain out of me because I realised I hadn't got any sort of visa. I'd got the ESLA equivalent, I can't remember what it's called, electronic visa waiver. But I hadn't considered the fact that I might be classed as working in Canada. And I hadn't thought that they'd asked me that question. So I said, well, I'm going to visit a company because I might be working with them in the future. It's just a meeting. So I was trying to make it very clear I wasn't getting paid for that trip. It was just to discuss possible work. So they said, oh, fine, but you'll have to go and talk to the person in the desk around the corner. So I went around the corner, and as I got around the corner, I saw the desk they were talking about, but there was quite a big corridor going past it, and there was a lot of space. So I kind of thought, sure, I could walk past here without them even knowing, but I didn't want to risk that, obviously. So I went up to the desk and handed my passport in, and they proceeded with similar questions. You know, why are you coming to Canada? So I said, well, I'm visiting the company because to discuss how we might possibly work together in the future. Still pleased with myself for that line. And she said, so what's the nature of your work? So I said, computing, because as we all know, most people don't know what requirements engineering is. So she asked what the company was I was visiting, and I told them the company and some of their products and so on. So she's obviously looking on a computer, I presume looking up their website to see if that company existed. And then she asked me my details. So I said who I was and what I was known for. So she looked at my website, I assumed, to see who I was, and that EARS was a thing I'd invented and had some credibility. But she still didn't really understand why I needed to go to Canada to help people. So I had a couple of goes at explaining what requirements engineering was and why they needed me, why they were interested in talking to me. And what I said was that, you know, I was helping them write what the requirements were, requirements being what a system should do. So I was helping them define the requirements for a system. And she said, well, doesn't everyone do that anyway? And I said, well, you'd think so, wouldn't you? And she was still trying to be professional and sort of being a little bit official, of course, but Canadians are notoriously very polite. So she saw there was a joke there, and we sort of lightened the atmosphere, but she was still doing her job, and she was still a little suspicious. So she was asking a little more, and I thought, I'll explain again in a different way. So I said, so for example, that system you're using, is it easy to use? And quite obviously not. And she was sitting and she looked at us to go, obviously not. So I said, well, if I'd been involved in helping to define the requirements for that system, I would have talked to passengers to say, if you're asked by the immigration to stop and explain yourself, how would you like to be treated? What sort of things would you like to know? How would that scenario be for you? People like herself, I said, happened to be a lady immigration officer, woman. I said to her, you know, I'd interview people like you and say, what do you need to do? What scenarios would you come across? What different types of traveller would you deal with? What types of information would you need to make it usable for you and other stakeholders, etc. And she looked at me and went, oh, approved for Canada. So she now understood what requirements engineering was. But what's my point there, apart from a story? My point is that she's not interested in the software or a software solution. She's interested in what the system does for her. She's interested in the system. So some other theoretical basis that some of this might be related to. So scenarios. Oh, sorry. Use cases. Use stories. So interestingly, I would say Jackson's World in the Machine comes out of software engineering. Activity diagrams, software engineering. Use case diagrams, software engineering. User stories, agile, software engineering. And yet all of these, the emphasis is on the system behavior. It's what does the user want the system to achieve, not the software. So users don't care about software. Another story. So that's a Singapore flag. I wouldn't have known that. Google helps in these things. So a confession about this story. I think I heard this story at a requirements event. I can't remember whose story it was. I don't even know if it's true, but I like the story. If someone knows where the story comes from, I'd be interested to hear. I can't remember. The story goes that someone was involved in pitching for a system that a hotel, a very expensive hotel in Singapore wanted. So they wanted to know if a guest had stayed in the hotel before, so that when the guest arrived at the hotel, they would know if they'd been there before, and they could then treat them with the respect of someone that they already knew, and they'd know something about the fact that they'd been there before. So this person who was involved in trying to pitch for this work, they'd looked at various different solutions like, iris recognition, facial recognition, things that maybe wouldn't recognize the way people walked and so on, as ways of noticing individuals and whether they'd stayed at the hotel before, and presumably, accessing records for how often they'd stayed or whatever the data protection might allow, so that they could be friendly and familiar with people who they knew had been before, maybe make their stay more how they liked it from previous visits, I assume. So anyway, this person was involved in trying to get some work with the system, didn't get it. Many years later, they happened to be in Singapore again, and they went to that hotel, just out of interest, and they went in and they went up to the reception, and the reception said, hello, Mrs. Smith, nice to see you again, making up the name. And Mrs. Smith said, oh, that's interesting. Would you mind telling me how you knew that I'd stayed before? And the receptionist said, well, I'm not really supposed to say this to you, but what we do is we pay the taxi drivers to ask people whether they've stayed before. And when they come in, if they've stayed before, they put the bag down on one side of the desk. And if they haven't, they put the bag down on the other side of the desk. So the system was effectively is no system. The system was the taxi drivers ask. There was no software. So people don't care about software, people care about the system effect. That was a solution that didn't have software. It wasn't a complex integrated socio-technical system. It was a simple thing. So running out of space a bit. Where am I going? I'll go back up here. So users are real people. Users are real people, and real people are all, sorry, a bit of gravity there, are all different. users are real people and real people are all different. What do I mean by that? It's partly just an excuse for a story, but I'll relate it back to this presentation somewhere. So this story came to me because I'm in my spare room that doubles as an office, and this picture happened to be in there, and I always remembered this line. This is my son Jim, who's now 18. He was a bit smaller then. You probably guessed that. Even when he was very small, he used to say some quite deep philosophical things. And I'm a fan of taking quotes and interesting things from lyrics of songs or things you overhear on a bus or 7-year-olds' words of wisdom and applying them as learning points in work. So what Jim said to me one day, he came up with these philosophical things out of nowhere. And one day he said to me, when he was about, I don't know, 7 or 8, he said, "Dad, you know, I don't think anyone's really normal." And I thought, yeah, okay, I'm sure there's more coming. And he said, "Think about it." He said, "What would normal be? Normal would be if you were average at everything. But if you were average at everything, that wouldn't really be normal, would it?" Which I thought was quite philosophical and interesting, but also for me has some connotations for requirements engineering. We tend to, in requirements and in systems engineering, software engineering, requirements engineering in general, we tend to think about personas and typical users and so on. And we tend to stereotype people as novices or advanced users or different stakeholder types. But of course, everybody's different, which I think is a lesson for us as well. And again, in systems, as opposed to software, in a systems type view, when you think that every engineered component is slightly different to every other one, you're perhaps more likely to think that every individual, every person is different to every other one. Perhaps with a more software-y mindset, you think of users of particular types and you perhaps tend to think of them more as all being the same or within set groups. So relating to that, that people are humans and people are quirks and they're all different and life's not simple. A large company I used to work for, I won't mention them, they had one of the criteria for continued professional development was that you had to show an ability to handle ambiguity, Interesting. It always amuses me the way people use the word ambiguity, often to cover several different things. So they're using the word ambiguity in an ambiguous way. But also in this particular case, I think they didn't even mean ambiguity at all. I think they meant uncertainty. What they meant was, at the beginning of a large complex project, you don't know everything and you have to move forward with incomplete knowledge. So not knowing everything is different to things being ambiguous. Things being uncertain is different to things being ambiguous. And that again is just another human interesting thing that you have to consider. I think more perhaps systems, people with a more systems view rather than a software centric view, perhaps people would be more likely to think about that. And I would argue that in general, requirements engineering is fundamentally a human discipline. So relating to that, systems, systems are for people. Systems are for people. So I've got another silly story related to systems are for people. Well, you'll see why it's a silly story. So quite a few years ago, I was working on a project at the early stages of a project to build what's called the Severn Barrage. The project, it didn't happen in the end because of the recession, but it was this big project that was envisaged for, that's supposed to be a map of the southwest corner of England. So where the bottom bit of England sticks out down into the Channel and towards the Atlantic, and then you have Wales here. This is the Severn River, and it's apparently the second biggest tidal flow in the world of any river. And the idea was to build a barrage across here to generate electricity. So it's basically going to be a huge wall, like a dam, full of turbines to generate electricity. So I said that requirements is a human discipline and systems are for people, but some of the stakeholders for that project were, interestingly, fish and birds. So because of the big tidal flow of the river, there were some migratory fish that would go up and down the river every day. So they'd have to go through the turbine there and back every day. So the guy who was working on the project, the sort of project leader, I met him at one project meeting, and he said he'd just been to see a fish psychologist. So I tried to do an icon of a fish psychologist. On Google Images, there's a psychologist, so there's the guy sitting, and then there's a person on the couch. So I thought it would be a fish on the couch for a fish psychologist. So yeah, stakeholders aren't always human, and that's perhaps a more complex thing in systems. I don't know. How are we doing for time? Okay, let's wrap up. Yeah, let's wrap up. So. So software and systems and the differences between them. So I think I've given quite a few reasons why software and systems are different, why I believe systems are bigger and more complex than software. So perhaps we should move this, and instead of it being a separate heading, perhaps blue type. Perhaps software is a part of systems. So I would say that if your notion is that software is complex, is inherently more complex than systems, and yet software is a part of a contained system, then by definition, systems are more complex than software. So requirements are for software because software is more complex than systems. That's a load of rubbish. Thank you.
All right, thank you, Mav, for that thought-provoking and compelling keynote. I would like to invite everyone, if you have questions that you would like to ask. I believe there is a question, and I also believe I need to figure out how to turn on my camera. Let me see if I've done that. Ah, yes, I've done that. So thank you, and I believe that there is a question box in the lower left-hand corner, although we also have the chat window. So if anyone would like to address questions to Mav about the keynote, please go ahead and enter those into the relevant boxes, and we will follow them. I see Q&A in front of me. I bet if I click on that.
So Sarah, are you going to select questions for me so I don't need to look?
Yes, I will select questions for you so you don't need to look. How about that? So first question, let's see, don't you think the software is the core of a system but is as important? Even if users do not really care about the software that doesn't work accurately makes the whole system not really usable. Do you have a response that you'd like to share with that?
I completely agree, but the reason they're not happy is because the system doesn't work. It may be in that instance the software doesn't work, but the software is part of the system, and what they care about is the system behavior. And I'm not arguing, I don't mean to argue that software isn't complex and isn't important. In many systems, software is the bulk of the system, and it is extremely important, and the system would not work without software, of course. But users care about systems. Users do not care about software. So yes, the failure could be within the software. The bulk of the system could be software, and therefore realistically some of the failures could come from the software, but ultimately it's has the system worked is what people care about.
Okay. Then a comment from Dan just that with earlier in the talk, the reason we say software X rather than system X is that among all the components of a system, only the software is both deterministic and flexible enough to be truly, totally programmable. with guaranteed compliance to its specification with any specification we have?
Sorry, is that a question?
Statement, I believe, but any response that you would like to have. And that one, there's some complexity in there. It may be good to pull up the screen if that would help you.
Well, if you, I don't know if the questioner wanted to clarify. If I'm not, I'll attempt to answer it or address it. Okay. Software can indeed be very complex. Software, I think in the comment, whether it's a question or not, in the comment, it's saying that software is deterministic and can do exactly what the requirements ask of it, and you can prove that. In a way, that's my whole point, is that software, of course, software can be complex. I'm not saying it can't be complex. It can be complex. The requirements for it could be very complex and far from trivial to do. I'm not saying that either. But the point, as the questioner says, is that a good set of software requirements implemented well, you can prove that the software does what the requirements say. In that sense, that makes it easier, not trivial, easier to do than for a system that includes hardware and users, which are inherently less predictable. So I would say that that's almost my exact point, that software is more predictable and easier to prove that it has done what you wanted it to do. So I think that's part of my point. So I don't see there's a question there, or certainly not anything I disagree with.
Okay, it was sort of an assertion at the beginning and then asked what you think of that claim. So it sounds like that claim is consistent with
I would say so.
Yep, okay. Yeah. Question from another angle from Anna. What is your definition for real? Being software part of a system, does it become real?
I presume that's when I put that a system is real and software is abstract. Well, it's a real thing when it's coded and tested, so it exists. It's real in that sense. But I think I perhaps meant more that software is always intangible. You can't really see it. So that's fundamentally different to hardware and users and things that are physical things that you can see and touch. So they have all the complexity of physical things, of connections, of inaccuracies and tolerances and engineering differences and all that type of stuff. Yeah, I think I meant more that it is inherently abstract. You can't take a picture of it, you can't see it, you can't touch it.
Any other questions? There's another statement that I have to give you. I'm not sure also what the time limits that we're working under, Alistair. I think we've got time for maybe one or two more questions.
We are okay with time.
I believe we have an hour for the whole session, so yeah.
Oh, all right, okay.
Yeah.
Actually, I do have a question, but I could not type it in the Q&A. This is Liliana Pasquale. Thank you for the nice talk. I was wondering if you can give you some highlights of what are the gaps and the challenges that the requirements engineering community should address in this space to consider the system.
Okay, well, I think in simple terms, as I said at the start, I think there are a lot of people who either implicitly or explicitly, when they're talking, presumably in their papers as well, but when they present, people talk explicitly about software systems, which implies, at least, it may not always be true, but it implies that they're only really considering the software and therefore the requirements for the software. I just think as a general thing, this is perhaps a sort of a polite reminder to people that they need to think about non-software elements of any system. Even if they consider their system to be a software system or a software intensive system or whatever badge you want to give it with the software word in it, it is still a system. And as I said, several of the provocative things on the wall, you know, people don't care about software, people use systems. Even something that you might perceive to be inherently software, if it's showing something to someone on a screen, then the screen is not software, is it? You know, if it's giving an output to another system, then how often is that signal sent? In what format? How is it connected? These are system issues, not software issues. So there is, to my knowledge, there is no system that is only software. A system that does something useful is more than just software. So you need to consider those other things just as well. I mean, the example that I used to the individual who did the quote that I threw away, when that was mentioned at an RE roughly 5 years ago, I said to that individual, when you're flying home from the conference, if you look out of the window of the aircraft at the engine, if you were told that the software for that control system was written against requirements, but the rest of the control system, the rest of the engine was not written against requirements, would you be happy? Are you telling me that it's only the software that you think is safety critical? Surely not. The whole system needs to be safe, so it all needs requirements to the same level of rigor. Otherwise, it's not safe. And whilst you may or may not be working in safety critical domains, and you may think that your system is primarily software, I'm asserting that I don't believe it is ever 100% software. There are some things that are not software, and they should also be considered in a requirements engineering effort.
Okay, thank you.
This is somewhat related, but maybe a little bit more pointed or specific for audiences. I agree that users care about systems and not software. So what are your implications for RE research? What do we need to change or do differently?
Well, at the risk of repeating myself, I don't want to hear anyone ever stand up at a conference and say something about a software requirements, or rather not a presentation that is all about software requirements, because the system is more than software. I've said that more than once. That is probably the main thing. I mean, obviously there's things behind that. I've only briefly touched on some of the complexities, some of the issues that come up out of hardware things. I mean, a lot of stuff that comes out of safety engineering, I think is very useful in requirements engineering. One of my most common co-authors, Phil Wilkinson at Rolls-Royce, whilst he's a general systems engineer, he's got a very strong safety background. And a lot of the stuff that I do, that we do together in papers and so on, is built off a lot of his safety background. You know, things like HAZOPs, where you have guide words of, you know, what sort of things can go wrong with any component, any system. Things that happen too often, not often enough, too quickly, too slowly, intermittently. All these type of guide words for the things that could go wrong. And many of those may come out of safety engineering, which is principally, originally, predates software engineering, let's say. So it's more about systems as a whole. And that type of thinking that we can borrow from related domains like safety engineering, I think is very useful. To me, requirements is a big, broad discipline. And I think perhaps more generally, requirements engineering is a little bit insular and looks to, let's say, computer science and computing, IT type domains, and learns from that. But actually, it should be a much broader domain. We should be looking at, I mean, we look at cognition and learning and so on, and, you know, human factors. But I think, you know, we should always remember that it's a multidisciplinary domain. And as I say, things coming out of safety engineering, I think, even in a primarily software system, so a system that is mainly software, perhaps having that kind of safety type angle to think about what could go wrong would make your systems more robust.
You may have just touched on a couple of the other questions, but let me start with one. Do you think we need to push more for evaluating software within a system exactly as much as we evaluate software as a standalone unit?
Well, if I understand the question correctly, if you tested some software as a standalone unit, that's fine. It does what you expect it to do. But to be effective, it is part of the system. So you would have to test it as part of the system to know how it was really going to behave when used in the real world, you know, by users as part of the system. So the answer I think is yes. I would say people should always test software as part of the system. It's like I don't know, testing the engine of a car, but not testing the whole car. That couldn't make sense, could it?
Our brain filters and interprets the reality of the systems we interact with. Things move as people are typing in questions. I'm sorry, let me see if I can find where that went. Okay, our brain filters and interprets the reality of the systems we interact with. Does that mean there needs to be additional focus on psychology and neurology as well?
Short answer, probably yes. I don't know if this is quite the same point, but I think people have a way of thinking about things, and perhaps I was sort of trying to touch on this on the two types of people thing at the start. You know, the people who are inherently logical and the people who are inherently probabilistic, if you like. I've also, in another similar, you know, dichotomy of types, is people who are digital and binary, by which the way it was explained to me in the particular case, binary and analog. People who are analog, if people get stressed or angry or something, if they get progressively a little bit more stressed and a little bit more angry or a little bit more happy or whatever emotion it is, and you can tell how they are because, you know, they vary. They're sort of analog people. And then there's digital people who appear to be calm and then will suddenly snap, or who appear to be working really well and then they're suddenly very, very stressed. So they're digital people. They're either on or they're off, if you like. So I think there's many ways you can categorize different people. And as I said, no two people are the same, you know, no one's normal and all that. But we all make mental models. And I think we have to consider that. I think one thing that I often find when I'm using any sort of computing device or any product, in fact, is that sometimes it just doesn't feel intuitive to me. And I think it's because the mental model of how I think it should be used, I don't match the person who designed it. They've not either not made it for me, maybe it's simply not intended for me, or they haven't accounted for people like me, and it just doesn't seem to work. It just doesn't work for me because it's not intuitive, if you like. So, and I also think that in effect, computer programs have a kind of a mental model of what the world is, because that's what's programmed into them, because the software is an invented reality, and it often mirrors the world view, the mental model or map or whatever of the world that the programmer or the person who specified the system, it matches them, matches how they think the world should be. So I think the short answer to the question is yes.
We'll schedule that for a subsequent conference then. Okay.
Yeah, sorry, if some of these things have raised other questions, or I haven't answered it as clearly as people might like, then obviously there's the follow-on sessions. I'd be more than happy to discuss these sort of things.
Yes, absolutely. Okay, a comment from Martin that I think is relevant to what you were saying as well. Engineers tend to migrate complex tasks from hardware and devices to software because they believe the system becomes cheaper and more flexible this way. So we tend to end up with the major problems moved into the software. At the end of the day, this is the reason why RE is concentrating so much on software.
There are cases of that, yeah. I'm not going to mention specific companies, but I have worked at companies where the sort of joke was with the hardware people that it doesn't really matter what we do because we can fix it in software later. And it was sort of said as a flippant, jokey thing, but in some ways there was an element of truth in it. People felt that you could fertile it, fix it in software later. That is a bad attitude. That is not very realistic. Obviously, software is quite flexible, and you can do a lot of clever things in software. But if the system as a whole is not really designed well, and you're trying to fix it in software, that's clearly not a very good solution. So to some extent, I can see the point, yes. Complexity is sometimes heaped on software. It shouldn't be. Perhaps it's reality that it is, and maybe that does lead to some of the difficulties in software and why requirements engineering for software, it can be more difficult. Agree with that. But I suppose perhaps I'm saying that if people thought more about the wider systems aspects in the requirements phase, then you'd be less likely to get into that situation in the end.
And speaking of systems being complex and challenging, I'm bouncing back and forth between the webinar chat and the Q&A. Nazim, yes, go ahead, and since you're a presenter, if you'd like to go ahead and speak your question, do that, because I'm not finding it in the Q&A chat. So go ahead.
Yeah. Yeah, thank you, Sarah. So for some reason, the user interface on my Q&A doesn't have a box to type in the question. So I wrote it in the chat. So we in the RE are often insular and increasingly less so as we move in time. We have a developer's point of view, which is why we use the term software more than system. However, over the years, in RE, we have come to know about system behavior. This is why, for example, we talk a lot about, originally we used to call them non-functional requirements, and now we call them quality requirements. And clearly we're thinking about system behavior at runtime. And we think about the users using the system and the environment. So it's very much aligned to what you're saying. But I think we have transitioned as the RE community and indeed software engineering community from very insular view to general more and more acceptance of the world around us, the users, the customers, the environment we interact with, the systems interact with. So it's more a comment than a question. And there are, of course, conferences like INCOSE, which actually exactly deal with interaction between software and hardware, for example. And if they think about building a system, and we have a number of people in the community, of course, doing projects in the systems engineering area. So that really means not only a hardware, not only software, but actually the total system. So I think we've evolved a lot over time. But we do often find into a comfort zone and think about software because that's what we focus on at any given time in terms of the actual material we play with, you know. So that was just my comment.
So maybe to reflect that, from next year, REFSQ, the S should be system then.
I'm open to any of these kind of changes, and in fact, a lot of my work is to do with systems engineering as well. We deal with, for example, train systems and dealing with compliance projects, and we actually deal with systems rather than just software side of things. And so I am total, but I'm just saying that I think we do need focus on software at some point because it's a material we're dealing with, though its effects and its runtime behavior naturally swings into the wider context. So yeah, I think we're aligned, but I think it's just to put into perspective that we're not deliberately myopic.
No, I agree. And I mean, obviously, you know, you do need to do requirements for software, and because software is abstract and you can't see it and touch it, it's probably in that sense more important that you need requirements for it, because it's a slippery, indistinct thing. But I'm not saying that it's not important. I'm just saying it's part of systems.
Oh, yeah, totally agree. But you know, even if you look at our RE books, you know, and what we've learned is you can see the transitions in the content of those books over time. You know, from the system shall do this, the system shall do this, to something like how you want the system to behave at runtime. And you know, let's think about, you know, when the system is actually running and using it, how do you want the system to work at that time, and its effects on the environment, be it people or whatever, and then capture requirements from that. And I think it dates back to the ideas of Michael Jackson and so on, that they've even talked about system behavior. And so I think it's a matter of gradual awareness of things and over time. But I really enjoyed your talk. Actually, it was fantastic.
Thank you.
Quick time check. Do we have time for one more question, or are we at the top of the hour and need to move on?
I'm happy to do another one.
I'll do one quickly until somebody from the organizing committee jumps in. The term requirements engineering doesn't mention software or system. Why restrict it to hardware and software and not to any system? Things we see around us, roads, buildings, furniture, books, in the absence of any technology.
100% agree.
So requirements engineering, the foundation of
stuff.
Stuff quality, everything. So many things that we can do with the S.
I didn't really even think about stuff was also an S, but yeah, let's say that.
Okay, next year. Okay, if those are the questions that we have, I'd like to thank you, Mav, again, for a very enlightening and compelling keynote. Lots of things to think about here, lots of sticky notes.